So this is question 10, and we just need to solve this equation. So first, I've listed all of the potential zeros, just factoring the constant, which is the negative 12. And then the leading coefficient is 1, which is nice because that's just a factor of 1. So my potential zeros are all listed. I've got positive and negative 1, positive and negative 2, and then 3, 4, 6, and 12. So I have a lot of potentials. So what I've gone ahead and done is I've looked at a graph of the function, and I know that 3, which is a potential zero, is definitely a 0. So I'm going to choose to use synthetic division to try to break this quartic, this 4th degree polynomial, down into a 3rd degree polynomial. And so I'm going to just write my coefficients. So I have 1, 2, negative 7, negative 20, negative 12. And I'm going to just use that synthetic division process. 1, drop the 1. 1 times 3 is 3. 3 and 2 is 5. 5 times 3 is 15. You add them up and you get 8 times 3 is 24. Negative 20 plus 24 is 4. 3 times 4 is 12. The fact that my remainder is 0 is basically reinforcing that 3 is definitely a solution. It's definitely a 0 for this equation. So the next thing I need to do is I'm going to forget about the remainder, and I'm going to realize that these 4 numbers, 1, 5, 8, and 4, really represent a cubic. And the equation of that cubic is 1x cubed plus 5x squared plus 8x plus 4. And so what I'm going to suggest you do is look at that cubic and see what its zeros are. And I would recommend you pick one of the zeros and perform synthetic division again. When you're finished with this synthetic division, you're going to be left with a quadratic here. So you're going to have some number x squared plus some number x plus a constant. And so I would recommend here, you can always use factoring, or you could use quadratic formula in order to find the remaining 2 solutions. Because it is a quartic, you should find 4 solutions altogether. So x equals, one of the solutions may occur twice.